Hey everybody, how you guys doing today? Happy Thursday, hope it's going well. Got a couple things on tap today. Looks like most people got Project 2, and I'm missing a couple here from people who took the midterm. Again, sorry that kind of ended up back to back like that, but you know, we had, I think, a decent amount of time for Project 2 to get it done earlier. Hopefully that wasn't too stressful. No one seemed to complain too much when we planned it like that, so I went for it. I got everything, all your quizzes and labs up to date, graded. I'm still behind on this project here, so I'll be working on this probably over the weekend, and I can get those in for you. So we'll talk about Project 2 today and the midterm. If you guys have any specific questions about the midterm, I can, I can go over any of the questions if you guys are interested for the midterm there. Other than that, we're got Project 2 solution, and then we'll see if we get to trees or not. I wasn't sure how much time we'd have today, and we've got all next week as well for trees, so I'm not too concerned about that. And then given, there probably won't be much to do for a lab on Monday either, so we might see if we can just take that one off. We'll see how far we get today, if there's enough to do for a lab exercise. I'm not sure there will be. So we'll play that by ear. We'll see how it goes now. But let me know if you have any midterm related questions. I'll take those first. And then we can talk about the Project 2 while I fire up PyCharm here. So I am on pot number 2 of my espresso, my mocha pot. So I did switch to tea. I finished off both of those pots already. So hopefully I won't go too fast. All right. Yeah, and we are officially past our halfway mark now. We've got March and April to go. And I think updating my video card drivers fixed my Zoom screen sharing issue, so we should be good for final project presentations, I think. I'll have to see what time our final exam time slot was, but the idea was we would all get on Zoom and we can present our final projects to each other. That time synchronously is the hope. And that time shouldn't conflict with anybody because they scheduled these final exam slots to fit nicely. So, okay. Another linked list one. All right, well, nobody had any midterm questions. I can jump right into Project 2, I guess. One more call for midterm questions. Hopefully it wasn't much of a surprise, and it was just a boring midterm. I got a couple questions on Monday in our lab time we reserved for midterm review. Yeah, other than that, I didn't hear a whole lot about it, so hopefully it went well. I'll be working on grading those over the weekend for you. Okay. All right, cool. So let's do this. Let me, remember the idea with this project is we wanted to have some object-oriented design. We want to separate out our business logic from all of this, text processing, user input stuff here. We want to be able to use this anywhere. So I want to have a separate class here. Well, maybe we'll call this the dock. And the dock's job is to unload the ship. Okay, so we're going to write a class for dock. We'll define an init method that takes some info here. So to be able to unload a ship, we probably need that ship info. And we probably don't need to go quite so far as to have a ship object that has all of these properties. We could probably just ask for these sorts of values here. So we needed the train item list. Train item list. We needed the plane item list. We needed a before the item list, right? This is the train, maybe train list, plane list, train item list, and plane item list. So really this first line here, we could actually mostly ignore because we're assuming the input was good. It'd be nice and all well and good to do some checks on that, but I didn't ask for any of that this assignment. I figure at this point we can do those sanity checks if we need to. So this first line here for number of trains, number of planes, number of train items, number of plane items, we don't actually need this one, right? Because the sum of this and the number of those should match. So the count of those should match this, and the sum of those should match this. So we don't actually need that first line. We'll be able to throw that one away. If you used it, fine, doesn't matter, doesn't hurt anything. And if I just get my train list with the capacity for each train, and I get my plane list with the capacity for each plane, I'll be good to go. Does that part make sense? Cool. So then I'm going to assign these. So I'll have a self. I don't need the train list itself. What I want to do is have a bunch of trains. Right? Equals a new list. And then I want planes equals a new list. Right? And then what I want to do is I want to have take all these train items and put them into a queue of stacks. So I need those queue and stack classes that we wrote. So we can go get those out of our GitHub here. Let's take a peek. I think we've got those over here. Queue, let's see. Stacks and queues. So could probably use, the stack was fine. We had a faster dumb queue. That one's still not great. We did a better job with queue somewhere else, didn't we? Let's take our stack class at least. Why not? Why not make a new file for it? It's not going to hurt anything. We'll call it stack. Paste it in here. That should be fine. Okay, stack was easy, and I'll just add a new class for queue. And I think we've got a better queue out here, right? This was our lab where we did the circular queue. Let me go back and look this up here. Yeah, our circular queue is much better. So let's see. We don't need that raw contents because we're not actually doing any of that. So we'll see how well this one works for us. And I'm just going to call this a queue here. I'm going to take out the circular queue name. And I'm going to leave a reference because that's the right thing to do. Right? Oh, sorry. I should put my phone on quiet here. Okay. Yeah, that one's on quiet. And, actually no, I just muted that. I need to, oh dear. There's the vibrate mode. Got it. All right. And then our stack class, that was the other one I copied here. Let me go grab that from here. This was our stack. Okay, good. So now in doc, then we need to import. So we'll say from doc import doc, or I'm sorry, from stack import stack, and from queue import queue. Okay, then, so now our train items can be a queue. Remember, we're going to put stacks into this queue, and our plane items can be a queue. Okay, now we've got these, right? These are all my self variables here. I am ready to go. Now, I probably want to break these apart, right? We want to do this functional decomposition. We want to take a big problem and break it into smaller problems. So let's have a method like self, I don't know, and this is probably a helper method, right? It's just a private method here. Doesn't matter too much one way or the other. We'll see. These could probably be private or public. We can figure that out after, but my helper method should probably be private. So this will be like load train items, given the train item list. Okay. And it's going to say, hey, we don't have one of those. Yeah, let's make a method. Perfect. Right? You let the tool do the work for you. Don't type anything yourself that you don't have to. So to load the train items, given the train item list. Now we want to do, for each item in the train item list, we want to do something. Right? And what we're going to do is we want to add it to a stack. And when the stack is full, we want to queue that stack. right? So we need to make a stack first. So my stack equals a stack here, and then for item in train item list, let's add to stack. So stack dot push the item. And then we need to check if it's full, if the length of stack equals 5. And I'm feeling a little bad about having a 5 here, right? Anytime we've got these numbers, these literals, we should feel a little bit bad about it. So I'm going to add a method or a variable here. We'll call this the max stack size. It's 5. And then we can use this up here. Self dot max stack size, right? Because this is a static variable here. It doesn't belong to an instance of doc. You just, for all docs, like it's a static, it's shared among the definition of the class, our max stack size. So if our stack is full, then we need to enqueue it. So we'll take our self.train items and we'll enqueue the stack. Then we need to make stack equal a new stack. Right? So we're going to loop through all of our items, putting them into the stack, putting it into the stack, putting it into the stack. If it gets full, enqueue it into our train items queue, and then make a new stack, right? Start the next one here. Then, now, you might not have caught this, and this will be a small bug for you. There was no guarantee that the number of train items would be evenly divisible by 5. So if I had like 12 items, I'm going to have 2 items left in this stack that did not get queued. So what I want to do is I want to check. I want to see if the length of my stack is greater than 0. Then I need to queue that partial stack. Right? Because it means I had some number less than 5, but I had some numbers there that need to go into the queue. Right? So that's the last queue. So this one's important here, that we didn't leave any off in case we didn't have an even number of 5. There was no guarantee there for 5. Okay? So that's how I load my train items. Right? Put them into stacks of 5, queue them up. And then make sure we get that last one. Okay? Now, loading plain items, sure, why not? We'll follow the same format here, but it's a little bit silly because it's super simple, but that's okay. And I've got a method here, and PyCharm says, oh, you don't have one, you want to make one? Yes, please make one. Okay, and we just say for item in plain item list, self.plain items dot enqueue the item. That's it. Just queue up all the items. So it's kind of silly to have that as a function, but sure, why not? It fits our pattern. Okay, this makes sense so far. So our doc's job, right, is to take the inputs and load them all up. Now I don't have trains and planes yet, though. Right, I need a way to store the trains and their capacity and the time that they were filled. Right, and trains and planes are actually pretty similar sounding here. So let's make we'll call it a train here. Why not? And again, I like doing one class per file. Again, it's just a habit of mine. I learned Java first. I like because it makes it nice and clean in my source control. If you didn't, it's okay. It doesn't matter one way or the other. If you put them all in one file, that's cool too. It's totally up to you. And again, different organizations will have different conventions for that. So, just follow along with whatever whoever writes your paycheck. It's generally the idea. You just follow that pattern, and life is pretty good. We're just finding the init method. So a train, right, knows its probably its number. Right? When you create a train, you tell it, hey, you're train 1, you're train 2, you're train 3, you're train 4, that sort of thing. So self.number is the number. And then the max capacity, right? Or expected items. I don't know, we'll call it capacity. Or number of items, sure. Number of items until full. I like that. There we go. That's nice and long. Number of items until full, and then self.time until full. We're going to start off at 0. Right? Until we know otherwise. And so this is the place to store this here. And now, how do we interact with train? Right? Well, we take items to the train and we put them on. Right? We don't actually care what the item is. We just need to load an item. And we probably have a self.current number of items, right? Start that one off at 0. This one's probably pretty important, right? Okay, cool. So we can do this. So then let's say we have a load item. We can load an item, sure. And let's say let's take a time, right? We'll take a current time. Elapsed, right? Time elapsed. It's not like the actual minute time. It's like how many minutes has passed. So current time elapsed. We'll do that. So we'll take our self.current number of items plus 1. And then if my self.current number of items is equal to the self.number of items until full, self.time until full is the current time elapsed. Right? You can do that. Now, train, depending on how we wanted to track the time here, we could do something with the time and return the time as well, if we wanted to. I kind of like the idea of the train will tell me how much time it took to load, or maybe that belongs to the doc, who knows. We could do it either way here. But if we wanted to, right, we should... Yeah, we could do that. So let's actually take our current time elapsed, and we're going to add to it the self.number, right, our train number. Because it takes that many minutes, so if we say, hey, we want to go load an item on train number 1, 0 minutes have passed. We're going to increase the time elapsed to 1 minute, then we can save that, and then we will return current time elapsed plus self.number, again, because that's the round trip. We could do that. Right? So when we call load item, I'll start at 0, and it's going to do the tracking for me here. Does that make sense? Let's go check the doc here. So this is actually, this isn't load train items. We should rename this one here. I want to refactor rename. This is unload train items from ship. I like that. This is us unloading from the ship here. Let's do that refactor. And we'll do this one too. This is unload main items from ship. We'll do that one too. Because then what I can do now in the doc, then once I've unloaded them, then I can load them up. Right? So I can say a current time is 0, and now I want to start loading these items on the ship. Well, I guess yeah, we'll do all that in the method, right? So we'll call self.load items on trains. Okay, and PyCharm should say, oh, I don't have a method for that. Yeah, let's add a method. Awesome. So load items on trains. Okay, so now we'll take our current time. We'll start off at 0. We're going to say while the length of self.train items is greater than 0 or not equal to 0. I mean, either one is fine. Let's start unloading. So we'll take the stack is my self.train items, DQ. Right, take the first item off, here's a stack to work. And then while the length of that stack is greater than 0, I can start taking those items off. So item is my stack.pop. Take the item off. Now I need to go load it on the plane. Oop, but I don't have my list of planes yet, or trains yet. That's right, so I need to add those. So I can say for what train in... So the values in train list, right? This is really, what do we have here? The train list, this is the number of items per train. So really that's a number of items per train list. So let's rename that one. So number of items per train list. And the number of items per plane list. So that gets a little bit long and awkward, but that's okay. We'll bump that down maybe. Okay. So start off a list, and then we want to say for, now I want the index here, because the index is going to tell me what train number it is. So I'm going to, for index in range, length of number of items per train list. And actually, I want to go from, because they're the train number 1, it's not train number 0. So I want to start at 1, really? And I want to go up to that length plus 1, right? Because I want to get that last number. So if I have 3 items, I want to get 1, 2, and 3. I don't want 0, 1, and 2. That's all. So I can take my self trains dot append. I can append a train, and it needs the number, right? So it's the index. And then train also needs the number of items until full. So the index is the train number, and then the number of items per train list. I guess that one has to be index minus 1. That's unfortunate. Okay, let's skip the 1 here then. We'll do just a regular range through the length. That way I can use index here, and I want to take index plus 1. And then we need to, from train, import train. There. Now we can actually make a train. Needs another parenthesis, index. Okay, because this is the train numbers, index plus 1, and then, well, the value that's stored there is how many train items it should expect. Right, we actually do the same thing here then for our planes. This is number of planes, and this is planes dot append planes. Right, so we go and make, oh, actually I don't want train though, I want to make plane here. I'll come back to the plane class, don't worry. We'll worry about that part after. You guys with me so far? And what's nice about having the train class, right, is it keeps all this information self-contained, and it can tell me when it's full when I tell it to load items. Right? Okay, so we've got that so far. So load items on trains then. All right, we took our item off. Now we need to go load it. Right, so I'm going to say my current time is equal to, I need to go find that train. So it's self.train, trains at index of the item, minus 1. Now, it's minus 1 because train number 1 is actually at index 0. Train number 2 is at index 1. Remember, because we're offset by your indexes here. So self.trains.load item, given the current time. Right? It's going to go load the item. I told it what time it was, so the first train starts at 0. It's going to give me back the time where it adjusts its own time here. Right? So train says, okay, to get to me, add my train number. Right? And then to get back, add my train number again. That's the round trip time. We all right so far? So as long as we have something, keep on popping the item, loading it, popping the item, loading it. As soon as we run out of items, right, as soon as this stack is empty, let's go back. As long as we have more in the queue, dequeue the next stack. Keep on going, keep on going, keep on going, keep on going, keep on going. That's it. And then we need a way to get those values back out, right? So we want to have a function for like get train load times. Right, so we're going to build a string here, and we're going to return that string of all the values here for our train load times. So we're going to have a result is a string here, and then for train in self.trains, result plus equals the train dot time until full, probably, and another space, right, to space separate them here. And we could do that in a fancy, join. You want to do it in a single line? I think we could return space dot join self dot trains we want train dot time until full for train in self-trains. All right, I think that's what we want to do here. Right, instead of doing this loop. We just do it in a fancy join. I think that'll work for us. Okay, so if I give it some train items, right, we're going to take the time until full for each of them, space separate them for every train in trains. Okay, we can do the same for plane load time. Get plane load times. Plane. Plane. Planes. Right, again, we don't have a plane yet, though, right? We don't know what this plane class is. But hopefully at this point, you're looking at train and you're thinking, well, the only thing different about plane is this. Right? I don't just add number. Right? Okay, so let's rename train here. Let's redo this here. We want to refactor rename this to some transport method. And then it needs to take this is what, a load time multiple? Something like that. And we'll default it to 1. So if I have a load time multiple here, self.load time multiple. So for trains, it's 1, but for planes, it's 5, because it's 5 minutes per one way, 5 minutes per back. And that's the only thing that's different, is that load time multiple. Or, I don't know, a distance multiple or something. I don't know. We can probably come up with a better name for it here, but load time multiple. I like that. That's fine. So now I don't need to make a train. I just need a transport method. And it's multiple here then. Again, we probably don't want to have numbers here. So this is a plain load time. I don't know, plain load one way time. Sure, why not? Transport method. Self plain load one way time. So they're all transport methods, right? So we don't actually need a separate class for plane, a separate class for train. They do the same thing, they just have a different multiple. Remember, that's the other benefit to writing classes. Right? Things that are the same, sure, let's share. We don't need to do anything super fancy. Okay, so what is it not like? Oh, just camel case. Okay, you refactor, rename, make it happy here. My mistake. Okay, cool. Okay, so I think doc is done. We haven't loaded planes yet, right? So let's load item on the planes. So load item on planes. And PyCharm should say, oh, you don't have a method for it? Yeah, well, let's add one, please. Come on, where's my little helper? Come on. Oh, do I have to type this myself? No? Need like another space? Okay, it's not cooperating. That's fine. That's fine. We can write our own. Define given self. Okay, well, this one's actually pretty easy here. I'm going to copy paste all of this, but we don't need all of it, right? We don't need the stack part here, right? We just have an item. That's my self-trains DQ. So this is the item. We'll just DQ it. We'll go to planes, index -1, load the item, given the current time. That's it. Oh, this should probably be plain items, right? Plain items. There we go. That would have been a bad bug. Okay. Right. So as long as we have plain items, DQ it, load it up. DQ it, load it up. DQ it, load it up. As long as we have items. So all of these are private here. Then let's see. We should probably make trains private, because we don't want someone accessing those directly. So I'm going to rename that to trains. And for planes as well, let's refactor that. Make that one private. We want to be good about our encapsulation. Right? Hide away all the details. They don't need to know these here. Right? If no one else needs to access it directly, let's not give them access directly. And let the tool do the work for you. Right? Refactor, rename. And you guys are awfully quiet. I hope chat is actually working now and that the stream didn't freeze. No one has had any questions yet, but that's okay. All right, so I'm just going to back that out because we don't need it. Okay. Awesome. So I think we're good to go. So main then needs to handle the input. Right? So we'll get a bunch of inputs. So we're going to have the, I don't know, the first line is just throwaway. So sure, that's fine. We'll just take an input there. And then we'll get the second line. This is the train, number of items per train list, number of items per train list is an input. And we want to split, right? Because we want to take each item and turn it into a list here, right? We want to space separate. So splitting it here is good. And then number of items per plane. And then we have a train item list, right? Train item list. And then we have a plane item list. Input dot split. Okay, and then we make a doc. So we need to import doc. From doc, import doc. And we pass it these things. We pass it our number of items per train, our number of items per plane, our train item list, and our plane item list. Okay, and then we're going to print doc.get train load times, and then we're going to print doc.get plane load times. Plane load times. I always like to do spaces, and it doesn't like my spaces. That's okay. So we can try it out here. Should we run it? And it's going to sit here waiting for input, so I should be able to come in here and grab this text. I'm just going to put it in the notepad real quick, make sure it's pasting okay. Yeah, I don't want all those extra white spaces. And I should just be able to paste in a bunch of lines. I want that last enter, though. I'm going to paste in all 5 lines here. Ooh, we're close. Okay. We're close. So doc.py here. Current items. I ran for string and it. Oh, yeah, we didn't convert them to integers, right? We expected all those to be integers. Okay. Sure. So we could turn those into integers. So we want, what do we want to do for? We want a list of the int I don't know, value or value in input split. Like that. No, my parentheses are round the wrong way, right? Int value. There we go. Let's try that. And we want to do that for all of them, right? Because we need these as integers. I forgot. Can't use strings. It's hard to do arithmetic with strings, isn't it? Okay. Run it again. Come back, get my copy, paste it in. Ooh, okay, we're close. So expected a string instance. So we need to get a string of time until full. And a string of time until full. We're getting closer. Let's run it again. Paste in the input. There we go. And we get some load times. Check that out. Did it match? 25, 36, 3, 65, 50. Okay, that's good. How about some other inputs, though? Should we make up some other ones? Right? We could probably talk our way through other scenarios and see how long it takes to load a bunch. Right? So let's run it again. Again, so the first line doesn't matter, so I can just give it empty. So if I have this is train item. So if I have one train with one item, great. And I have one plane with one item, great. One train item, one plane item. Should take 1 minute and 5 minutes. Okay, looking good so far. Let's try it again. So again, the first line doesn't matter. If I have one train with 2 items and one plane with 2 items, so 1 and 1 for train items, 1 and 1 for plane items, 3 minutes, 15 minutes, looking good so far. All right, so we want to test this out. You want to try it with different values here and see what you get. How you folks feeling about project 2? Again, just using stacks and queues, just getting some practice with, hey, if this fits our model, we can use them. You know, there's some advantages, right? Queues work really fast. Stacks work really fast. We looked at how we can optimize those. Essentially, it's a Python list wrapper. Right? The idea is that we don't want people to interact with the list the way that you can interact with the Python list. You shouldn't be able to insert a given item or jump around. You should only be able to take from the front, add to the back for a queue, or take from the top, add from the top for a stack. So we're limiting the access that we have because it fits our model. It fits the way that we're trying to solve our problem. And it doesn't always work that way, right? And sometimes, sure, we'll just stick with a regular list, and that's okay. But it's nice to know we've got these options, especially if we're going to expose any of this to outside classes. Right? If we want people to be able to interact with us, and we need to maintain that integrity, that idea that we want to make sure that our class, all of its details have been encapsulated in, and we're hiding away all anything that we're doing internally. We only want to let them interact with our public methods, right? Our abstract, our API, they can interact with us, and we'll give them access to do those public things. Still have nothing in chat. Are you guys there? Let me throw out a poll real quick. Project 2 feels good, okay, bad. Just let me know how Project 2 felt. Good, okay, or bad. There in the Twitch chat poll. And we'll see how you folks are feeling about it. See how you think. Okay, couple okays, one good. All right. Yeah, I noticed more people took the midterm than finished the project, which is a little concerning, but nobody reached out and said, like, it didn't work at all, so I'm not really sure what to make of that. Like, if you get stuck on something, please reach out and tell me. It's hard for me to know that you're stuck, aside from you not turning it in. So you got to tell me what's going on, especially since we don't actually meet in person. Okay. So a couple of you are hanging out. Cool. Maybe everyone else is just going to watch the VOD. All right. Because, a couple of you are answering questions. Did you have any midterm questions before we move on? We can talk about trees. We can work on trees. I think we've got enough time. This went relatively quickly, so let me put it here to my GitHub for you. Excuse me. If I can get GitHub to load. There we go. There, 2001. Got a bunch of new stuff. Sure. So this is project 2. Awesome. Commit and push. So I'll put this solution out here on GitHub for you. Okay, I think we're good here. Push. The emails I'm getting are not from you folks, so that's okay. No one panicking last minute. I heard Canvas went down yesterday. Hopefully that didn't impact any of your classes. I've got that friend who teaches chemistry out in Florida, and he had 200 students working on an exam when Canvas crashed. So that was rough. I feel real bad for that. That's a mess. Like that in my book is just like a do-over, or just we'll just forget it or something. But I don't know what he's doing. It sounds miserable. All right, so we're going to talk about trees today. Now, trees are a lot of fun. We are finally now looking at different ways of organizing data. So let me pull up my whiteboard here. And we'll clear this one out. Okay. That's fine. I don't think I actually need to be sharing it here, so we'll turn off the sharing. Okay. It's a cool feature. Like, I could share the whiteboard and you guys can also draw on it, which is fun. But I think we'll just turn that off for now. Yeah, that might be fun. I don't know, we could try that sometime, but maybe a different time to experiment. So far, all that we've done with our data structures is essentially put stuff in a list, which is ordered. Right? The order matters here. Right? Your index 0, 1, 2, 3. Right? And the order in which you go in is important because you expect to get that order back out. So with a tree, we forget all of this. Right? Tree is not storing a one-dimensional ordered list. The idea with a tree is it could have a value, some value, and then it has children. Really, as many children as you want. And the rule with trees is that each child is also a tree. So we'll call this one an N tree. Now this will be important later. I don't think we're going to get past N trees today, but we'll start looking at other types of trees later. Right? So that's V for value, right? These might have a value here. Value, 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 value. Right? So the definition of a tree is it's a data structure where we'd say this tree rooted here. This is the root node. Right? So we kind of draw them backwards. Right? Usually when you draw a tree, right, you've got the tree with its branches out this way. You know, here's the ground, right? All the grass growing, and you've got all these branches here, and these branches have like little fluffy leaves on them, right? This idea. And then some branches have other branches, right? And some of those branches have other branches, and they all get fluffy leaves on them. Imagine those are all fluffy leaves, right? That's usually how we draw a tree. Hey, that's not half bad. Not half bad. Okay? So what we get is, let's say this is the root here, right? This is the first value. Every branch then is a child, right? A branch is a child here. Okay? And that child then can have more children. So if they have children, great. If you don't have any children, you're a leaf. Right? Equals no children. So you're a leaf if you have no children. Okay? Otherwise, you might have children. Sure. So eventually, you have all leaves. Right? You might just have just one leaf. If it has no children, your root is also a leaf. Right? If it has no children. So that's okay. So now a tree is also recursively defined, which is the fun part. So a tree is made up of other trees. Right? Because this here is also a tree. Is a tree. It's a tree rooted here. So this tree, you might consider this to be a root. This leaf here is also a tree, rooted here. That's a tree. It just happens to be a leaf because it doesn't have any children. So a tree is made up of trees. So you have these generations and generations and generations of trees and trees and trees and trees until eventually you get trees with no children. So what you get here, this is essentially a hierarchy, right? Some sort of hierarchy, right? You've got the root level that has no parent, right? Great, it has no parents. This is the top of the tree, right? The top or the base of the tree. I don't know, we can use confusing words one way or another, top or base. And usually we look at trees top down, kind of inverted from our other tree over here. So that's just, you know, a little bit confusing, but it's probably okay. Oops, I didn't want to do that. I want to Lasso Select. Nope. Lasso Select. I don't know how to use this program, I guess. I thought Select would, like, let me pick things. Oh. I want to, like, grab all these things. Grab all of it. Yeah, can I flip it? Oh, it only lets me rotate some of it. Okay. I was going to rotate it for you. It was going to be really cool, but apparently I don't know how to multi-select in this. So that's okay. I'll learn more about whiteboard later. Okay, so a tree is made up of trees, made up of trees, made up of trees, made up of trees. So you might imagine something like the file system. Now let's see, let me just pop open a new folder here. Bring it up to my other screen. Okay. And then let's go look at our documents here. Let's go take a look at our GitHub directory. Here we go. All right, here's this GitHub directory. So we might imagine we have a tree rooted at the C drive. right? And there's a bunch of trees inside of that, right? One of those trees is the users directory. There's a tree inside of that. One of those trees is the Eric C directory. Document, yada, 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 yada. So, but each one of these is its own tree. So I could say here, the tree rooted at CIS 2001, winter 2021. Great. It has a bunch of children. Some of these children are leaf nodes, like the .git file, these high files. These have no children. They're actual files. That's the leaf. Some of them are other directories. It means they contain other things. Right? So this hierarchy structure, we actually see lots of places. So a tree is really useful for representing hierarchical data. Okay? It's not where the order necessarily matters. We're just going to throw things in. So we're just going to try out building a tree here if we can and see how it works. Knit. Now things tree probably knows, right? So self.root, right, is some value. So maybe we'll give it a value. Sure. We'll take a value. Root is the value, and then self.children equals a list. Okay. I don't actually like calling that root. We'll just call it value. Here is the value. And we probably know who our parent is, right? So if you don't tell me, I'll assume it's none. Self.parent equals parent. But if you do tell me, then great. I'm good to go. So if we can define an add child method, we have to add something here. We need a value. We're going to take self.children, and we're going to append a tree here with the value and self as the parent, right? We are that child's parent in this case. Sorry. I always like spaces after my parentheses. I got to remember not to do that. Python doesn't like it. Okay, so we can add a child. It makes a new tree with that value. Self as the parent. Cool. So we can add children, and we can add children, we can add children, we can add children, and maybe we want to give them back. Let's do this. We'll have a child is tree here, and then we'll append it, and then let's return the child. That way they can interact with that if they want to. Right? Sure. Let's see if we can use tree then. Right? So let's see if we can kind of model some of that structure off of it. So I'm going to make a tree. We'll call this one my root. There's a tree. We're going to say that is CIS 2001 winter 2021. Right, and we'll take root.addChild, and we're going to add, I don't know, we'll call it like lab1, maybe. This is lab1 equals, right, because they're going to give me back that child. I can say lab1.addChild. And here we'll add, I don't know, lab1.py. Sure, just pretend here. Okay, and then we'll take root, and we're going to add another child. We'll call this one maybe project1. Root add child, call that one project1. Great, and then project1 dot add child. So project1 needed what, the maze solver? So maze solver py, and then we'll take project1 and we'll add another child. We'll call that one the, I don't know, main.py, and then project1 dot add unit test.py. Sure, we'll just have some fun here. Okay. So we'll add a couple. So some have one child, some don't. That's okay. Let's add another one here. So we'll root.add child. We'll just call this one the hello world.py. Sure, we'll just add that right to root. It doesn't need to be another like directory level. We'll just pretend this is what it is. Okay? Now, how do we print this? Or how do we kind of explore this value here? Let's put it in debug mode, and we can watch it here. Let's run it in debug, and we can see the data structure here in debug mode in our variables. Let's see what we get. Okay, so we're going to step. So now we've got root. Root is a tree, has no children, has no parents so far. We're going to add a child. All right, now we have one child. It's also a tree. That tree has no children, but it has a parent, which is us, right? Its value is lab1. Great. Now we're going to add project1 add child. So now here, our children, we have two children, right? We have the lab 1 and the project 1 here. Okay, cool. You know, this will look a little bit nicer here if we add a string method. So if we define our string representation, if we overload this, we're going to return self.value. It's going to look a little prettier when we debug it, because then by default you get that string value here in the debugger view instead of that ugly tree at whatever hex address here. We'll step a couple. Okay, there we go. So here now root, right? We get the value of it, and then children. We open that up. Now we see lab 1, project 1. Project 1 has more children, right? Maze solver main. Lab 1 has some children. Lab 1. Lab 1's parent, right, is a tree. Lab 1's parent is lab 1. Right? And you can get silly here opening these up, right? You can open the children, you can open the parent, so just be careful kind of exploring this, because the child references the parent references the child. So gotta be careful kind of exploring that, but that's okay. Okay, and we'll add hello world, and then we're done. Right, so we can kind of explore, we can see it in debug mode, right? We can see that they have children, but how would we go and say, hey, I want to give you all of the values in my tree here? Well, we've got a couple options. We'll talk a couple more tree terms here. So trees have a couple properties, right? Trees have a height. The height of a tree, right, is like the number of generations. Okay, so this is our height. Let me just slide this over a little. This is height. Height. So a tree itself has the height. That's the number of generations. A given node in the tree, or a given tree in the tree, right, if you want to call it node, that's fine, has what you might call the depth. That's the wrong way to spell depth. And depth says, how deep am I? Right? How many levels up do I go until I've reached the root with no parent? Right? So depth is easy to calculate, right? Because we just go until we don't have a parent, let's keep going up. So let's see if we can calculate depth. So let's add a method here for depth. Define depth. So we're going to say current depth is 0, right? And we want to take our current parent. So the current parent equals self.parent. Self.the parent node. Go to the parent node. Okay, and while the current parent is not none, let's keep on going. So if I have a parent, let's keep on going up. Keep on going up, keep on going. If I don't have a parent, I stop. So while it's not none, I'm going to take current depth plus equals 1, and then current parent equals the current parent dot parent. Right, go to the parent's parent. Go up 1. If that's none, we're done. Keep on going, keep on going, keep on going, keep on going, right? So let's see then if we can check some of these out and see. So the depth of the root should be 0. The depth of lab 1 should be 1 because it has one parent. The depth of lab1.py should be 2 because it has lab 1 as a parent and root as a parent of the parent. Right? This is lab1.py. And let's check it, right? Let's just print some of these out. So we're going to print lab1.py dot depth. Okay, and we'll just keep on going. Let's print a bunch of depths as we go here. Root depth, lab1 depth, and maybe we'll say root depth. Here, you know what? Let's just do this. Let's copy that. Okay, lab1 depth. Oops. I like having colons and spaces. I think it just makes it look a little prettier, right? We'll just play with some of these. Okay, we'll just take a look at some of these depths. Oh dear. Root.depth. None type to string. Oh, we didn't return anything. Oops, we need to return current depth. Nope, depth. There we go. If we return a value, this might work a little better. Uh-oh. Can only concatenate string, not... Okay, so sure. Plus the string value of this. Yes, I want the string value. Oh, goodness. String. Okay. Let's upset with all my extra spaces here. Sorry. Boop, 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 boop. Okay, now let's run it. We're getting there. Awesome. So root depth is 0. Lab 1, 1. Lab 1.py, 2. Yeah, so it's looking good so far. So calculating depth isn't too bad, right? Just go up, 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 up. How about calculating height? Right? How do we start here and find our height? Any ideas how we might calculate the height of a tree? Now this one gets tricky. That's okay. This is a funny way to think about it. Now this is why we talk about recursion first, right? Because there's not really a good way to go into each child and go into each child and each child and each child, because I don't know how many children I have, right? It just doesn't, I don't, right? I have n number of children. There's no definition. And how many children do those children have? Unlimited, right? I could have 1,000 items in a tree, tall as I want. Right? So the height of the tree could be really big. So what we need to do is we need to find the max depth. Right? So another quick thing that'll help here, we can say define isLeaf. We can add a method, isLeaf. And we're going to return self.number of children. Length of self.children equals 0. If I have no children, if my length of children is 0, I am a leaf node, right? I'm a leaf tree. If I have children, that's false. So it's really, we only care about the leaves, right? We don't care. If you have children, obviously we don't care about your depth, because your children are going to have a higher depth than you are. So to define a height of a tree, well, we need to find the max height, the max depth of all of our children. Each of our children needs to ask the max depth of its children, and ask the max depth of its children. So this gets a little messy here, right? Because what we want to do is we want to say, okay, we'll go to all my children, ask what their depth is. If they have children, ask what their depth is. If they have children, ask what their depth is. If they have children, ask what their depth is. Right? So what we need to do is we need to go and find every child node and ask for its height. So what we're going to do is we're going to return the max of child.height for child in self.children. And that's a function call, right? So go to all of our children, get their height. Go to all our children, get their height. Go to all of our children, get their height. So if we're a leaf node, right? If self.isLeaf, return the depth. Right? If we're a leaf, count up. If we're not a leaf, right, keep on calculating. Keep on getting the height, keep on getting the height, keep on getting the height, keep on getting the height of our children and our children and our children and our children. Let's see if that works. I don't actually know if that's going to work. Let's try it. Print root.height. Okay, and let's put it in debug mode, and let's watch it. Let's see what happens. Okay. Oh, I don't need this breakpoint here, so I'm going to continue on. Let's continue. All right, so we're going to check height. We're going to step into our code. So is the root a leaf? It should say no. So now we're going to go for each child in children, calculate our children's height. Okay, remember, so self, we have 3 children. We have lab 1, project 1, hello world, py. So step into our code. Oh dear. Has no attribute height. Height. I spelled height wrong. Okay. Oh my goodness. You guys got to help me with that. And none of these here. Okay. Let's try that again. Debug it again. Okay. If we use the right method name, hopefully that'll help. Okay, so let's step into. Okay, now lab 1. Is lab 1 a leaf? No. Not a leaf. So we're going to go to its max of its children. Is lab 1 PY a leaf? Yes, it is. So we're going to return our depth. Okay? We need to get the max of that. Now we're in project 1. Project 1, is it a leaf? No, it's not. So we go to the max of its children. Is maze solver PY a leaf? Yes, it is. So return its depth. Oops, sorry, we don't need depth. We'll step out of depth. And we'll keep going. Now we're looking at, so self here, in this case, right? Where'd we go here? Maze solver, right? Okay, project 1. So we got maze solver. Oh man, the step's so fast. Let's see. Max was 2. All right. So I think that worked out. Right, so the idea here, right, is that the maximum depth of any node was 2. Right, so if we're not a leaf, get the max of our children's. If we are a leaf, return our depth. Okay, so the last thing we're going to talk about, and we'll call it a day, is what kind of performance do we get here? Right, so to calculate the depth of an item, right, so remember the definition of a tree is we have a node and it has n children. Okay, n children. Sure. There's no rule that says we have to have multiple children though. So, you know, you might have a tree that looks like this. Tree, 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 tree. Sorry, that should be a better circle. Tree. This is a tree, right? This is an n tree. It just happens to have 1 children. So to get the depth of an item, how many walks do we have to do? How many parents do we have to check? Well, that's n items. So our depth here is n. O of n. Depth is O of n. Right? Because I don't know how many items I have, and there's no guarantee of my shape. So my depth here for an n tree, that the amount of time it's going to take is n. And that you know, worst case, sure. Our tree otherwise might have other things. So like the depth of this one is definitely not O of n. But we have no idea. We can't really average it out either because we don't know. There's no rules around it here. So really, our worst case is n. Our average case is probably n as well. You know, slightly less than n, but remember we throw away coefficients. So like even half of n or a quarter of n or, you know, 1/10 of the time it's n means it's still n because we throw away those coefficients. Okay? Now height. Height has to go look at every item, right? Look at every child and ask what its depth is. So already we're O of n here to ask every child. Then once we get to a leaf child, we then have to do possibly n operations to get back for every child. Now we're skipping the leaves, thankfully. So if it is a big chain here, right, we're going down n and up n. Great, we're done. But if we're like a ginormous thing here, and we have a bunch of leaves here eventually, right, this has to happen some factor of n times, this has to happen some factor of n times, this has to some factor of n, some factor of n, some factor of n, some factor of n, right? It's really like for every n, it's possible we're going to do it n more times, not exactly n more times, but we get to some n almost squared here, not quite almost squared, but, you know, n to some exponent, right? Maybe it's like 1.4. Sure, 1.3, 1.2, whatever the ratio of leaves to nodes is, something in here. But we get exponential, right? Because every time I find a leaf, I have to do possible n, some factor of n operations again. So essentially we're n squared. We'll just round. Right? The math doesn't have to be perfect here. Okay? That's where we'll stop for now. We're gonna do we'll do a lab on Monday. We'll practice here with our n tree and see if we can play with this a little bit, okay? So let's plan for a lab on Monday. We'll play with the n tree. And let me get that committed to GitHub here. And you know what, let me rename this here. Refactor, rename, we'll call this one our n tree. Okay. There we go. And we'll play with it, we'll have some fun with it. This is an n tree on Monday, okay? All right, if you got any questions, any thoughts, any concerns, let me know. If not, we'll call it a day. You guys have a great weekend, and I'll work on getting that stuff graded for you, and we can go from there. So hopefully halfway through the semester, you're feeling good about your grade, and we can take a look from there, okay? All right, should we head out to this channel for fun? See if anyone else is around? Might as well, right? We'll see who's out there. If anyone wants to come along for a raid. If not, that's okay. That's just optional for fun. Let's see. Oh man, got a lot of... Hey, let's check out our nice music sponsor here. Why not? Let's try to see if we can raid their channel. Let's see. Silence. We'll head on over that way. Everyone say hi. Say thanks for the music. And we'll go from there. All right. I will see you folks around. And let me know if you got questions or concerns. We can talk. All right, take care.
I do pride myself in that, but at the same time, it is actually a problem.